All right, that leads us to actually the two-phase commit process. We're going to walk through each of the 3 local states in Git on our way to create our first commit. We left off in the GitHub-demo working folder of our repository. That's underneath the projects folder within our user's home directory. To git status, we have the same output that we had before, since we haven't done anything yet. And we really only have the README file. Well, let's change that. Let's use the command line tool, Nano, which is a command line driven text editor, to create a file. I'm going to call it start.txt. It could be anything, really. Once the text editor loads, we can type in anything we want here. This is an example text file. It really doesn't matter. I know that some people might be wondering, why aren't you using source code or something like that, like Java files or Python or something like that? And the answer is real simple. It doesn't matter. Source code is text, and that's what Git actually tracks. Git tracks text files. Now, whether they happen to have a .java extension or a .py extension doesn't really matter to Git. It just tracks the contents within those files, which must be of type text. They can't track binaries very well, so the only option left are text files. Once you've typed in some content for your new file, we're going to exit out with Control-X. Nano will detect that we have some changes in its buffer, that is, the area that we were typing, and give us the option to save those changes, which we want to do. So I'll press Y to continue. And although we passed in the name of the text file when we launched Nano, Nano will give us the option to change the text file name. To keep it, or simply press the Enter key. Now, if we do an LL, we should have a start.txt file in addition to the README file. Now, let's see what Git thinks of this. If we do a git status, Git tells us that we have untracked files. That's just Git's way of saying, hey, this is a new file. I have no idea about it. I'm not currently caring about it. So as a reminder, the 3 local states in Git is the working directory changes, the staging area, and the Git repository, that is the committed changes. We currently have a new file in the working directory. At this point, Git isn't aware of it yet. We actually have to add it to the staging area for it to become aware. We can test that out because Git has another command we can use to see what files Git is tracking. It's simply git space ls-files. And right now, Git is only tracking the README file. It's the only file that Git is really aware of. I mean, it detects the fact that there's a new file in the working directory that it currently isn't tracking, which is what that message is about. So we'll accomplish 2 things at once with the next command. We'll tell Git about the new file so that it can start tracking it, and we'll move these changes, that's the new file, into the staging area. And we do this with Git's add command. Git add, and then the file you wish to add, which is start.txt. Then press enter. Now, if we ask Git for its status, we should have a slightly different output. Of course, it tells us we're on the master branch and that we're up to date with origin master. Now it says, instead of untracked files, which is what we had before, that we have changes to be committed. We haven't committed them, they're to be committed. That's just Git's way of saying you have stuff staged. So now we've done the add command, which moves our changes into the staging area. Now, technically, those changes are in both the working directory and in the staging area. Like our new file didn't just disappear from the working directory just because we staged it. So staging is the first part of the two-stage commit. The next stage is to actually do the commit. Let's do that now. Before we do that, let's see if Git is tracking the file. Git space ls-files. Now we see that we have both readme and start.txt being tracked. That's all we had to do. We didn't even have to fully commit the file yet. Git started tracking that file the moment we added it to the Git staging area. All right, now we're ready to do the actual commit. Git commit, and then I want to use an inline commit message. So I use the -m option, and then in double quotes, the commit message I want to provide. Adding start.txt file locally. That'll make it easy for me to determine where the different commits came from. Once you're done with that, press enter. And Git should respond with output that looks like this. The first line will be simply telling us which branch we're on and the commit ID that's associated with the commit, followed by the commit message that we provided. Now, Git requires a commit message for every commit. It also tells us that we had one file change, that is the new file that we created, and it resulted in one insertion, that is the entire contents of that file. We also have a create mode, which is not terribly important. On Git Bash, it'll almost always be 644. Now that we've done our commit, we've moved all of our changes that were in the staging area into the Git repository and its affected history. And we can actually see the details of that commit by using Git's show command. Git show, and then I'm going to use a special reference called head, all caps. Head is simply an alias for the last commit on the current branch. Now press enter. This shows us the details about our commit. We start off on the first line that we have the commit followed by the actual commit ID. That's the full SHA-1 identifier. We also see in parentheses that our head marker is pointing to master, the last commit on master. Underneath that, we have the author information, which is myself. We have the email address that's associated with the author information, which is what we set up in our Git configuration earlier. Then, of course, we have the date that the commit was actually committed, along with an indented commit message. The rest of it, we have a diff, but that's not important because we simply added a new file. Now, if you had longer text here, you might not be back on the prompt. If you find yourself in that situation, press the Q button to exit out of the git show command. All right, let's move along. Now that we've moved our changes from our working directory through the staging area and into our Git repository, all of this has been local. We haven't done anything yet, put our changes back onto GitHub. This is the entire workflow we just went through on the local side. Now, let's go remote. I'm going to send our changes back to GitHub, and we do that doing what we call a push. So this is where we currently are. We have our changes in the working directory and the Git repository. Of course, the staging area is clear right now because there's nothing pending there. We need to use Git's push command to send our changes up to GitHub. Let's look where we are now. pwd, I'm currently in the working directory of our Git repository. Here are our files that are associated. And our Git status has been updated to let us know that our branch, that is master on our local system, is ahead of origin master by one commit. That kind of tells us that, hey, we have stuff locally that's not available on our remote side or GitHub. We can see that by jumping back over to GitHub, and just to make sure, we're going to refresh our page. So basically, nothing has changed. We're still on the initial commit, and we only have a README file. All right, let's fix that. Before we do that, I want to show you the remote reference that we set up earlier. We can do that by using git's remote command. Git remote and -v for verbose. Press enter, and then we have a remote name that is the remote reference that's named origin. And origin is set up by default whenever you clone from wherever you're cloning from. We clone from GitHub, and git's clone command simply set up a remote reference named origin, pointing back to our GitHub repository. And you can see that with the HTTPS URL right next to the name origin. Now, it is listed here twice, and there's a technical reason behind that, but for the most part, it's going to always be the same thing. So both of these should be identical. It's extremely rare that they would not be. So now that we know what a remote reference is, we can use it in the next command. Git push, followed by the name of the remote reference we want to use, which is origin. It happens to be the only remote reference we have, followed by the only branch name we have, which is master. I like doing this the first time, although additional times we won't really need it. We'll press enter. And on Windows, if you set up the credential manager as part of the installation process, you should be prompted to log into GitHub like this. I'm going to go ahead and provide my username and password. Once that's done, click on Login. And provided that you actually provide the correct credentials, you should come back with something like this. Now, the top several lines are not that important. It's just internal stuff for how Git communicates from the local system to the remote system. The last couple lines are the ones that we're interested in. It tells us where we sent our changes to, which is our GitHub repository. Now, of course, the URL should be different. It should show your username as part of the URL. And if you happen to use a different name for your repository, that piece would be different as well. And then the commits that were involved, exclusive. So the starting point and the ending point. And that we're pushing our changes from master, that is the local side of master, to the remote side master. So from my local repository, the master branch, to the GitHub repository, the master branch. And that's it. This was successful. Now, the reason why we had to authenticate is because although my repository is public, it doesn't mean that just anybody can push changes to it. I still have exclusive control over my repository. All right, let's hop back over to GitHub and see if our changes are there now. Like we did before, I'm going to reload my page. And now this time, I should have the new commit message and the file we added on our local side. If I go up here, I see that I have 2 commits. And this will be in reverse chronological order. Down at the bottom, I'll have the initial commit, which was created when we created the repository. And then the commit that we just added from our local side that was just pushed up here. And that's it. This whole process is the remote first approach. And we finally pushed our changes up to GitHub. So now our changes are in our working directory and in our local repository and in the remote repository. Here's a review of the entire process again. We start with our changes on the local side in our working directory. We added them to the staging area. Then we committed those changes, which affected our repository. Then we pushed any of our repository changes up to our remote. All right, well, that was it. Thank you very much for joining me, and please feel free to add comments below.